So in the first class we did numbers rationals, and in the second class we were at decimal fractions. So today we are going to start with the LCF and LCM now. Okay, is that clear? Yes, when you all are going to answer me, then I'm going to start that. Okay, I guess we do not have two of our students today. The first one is, I guess, two of our students. That means Mustafa and what's the other name of that girl? Maham. Maham. She's not there. Okay, students. So I just planned something for you that related to the LCM and HCF. And before that, I'm just starting from the basic concept of the LCM and HCF. Let me know, all of you, that are you aware about the LCM and HCF? Are you guys aware about the LCM and HCF? Yeah, lowest common multiple and highest common factor. Yeah, that's correct. It's the lowest common factor and highest common multiple. And as well as we can do one thing more, that we have some of the other things that which is related to this. Uh, let's suppose I'm having 36 and 48. Okay, so before starting anything, I'm gonna write the prime factors. Okay, so first we are going to discuss about the prime factors. What are the prime factors? And it is quite easily to say this, that in the prime factors, when we are talking about the prime factors, so we are going to calculate the factors by the help of the LCM and HCF, and that is quite simple to understand it. So for example, here we got 36, and if I am making a prime factors over here, so I'm going to write 2 into 18, 2 into 9, 3 into 3, and 3 into 1. Okay, so before going further, I'm going to say this, that 36 will be having the prime factors, like I can say that 2 square and 3 square over here. So it means that uh, 2 is in the prime factors. So 2 times I use 2, and 3 times 2 times I use 3 over here. And let's suppose when I'm talking about 48, so it's going to be like 2 into 2, 2 into 4, that's going to be 24. 2 into 24 is 48. 2 into 12, 2 into 6, 2 into 3, and 3 into 1. So it's going to be like 48 will be equal to 2 raised to the power 4 into 3. It means that I used 2 4 times and I used 3 1 time. So is that clear to you? That was quite simple, was it? So what about Simra? Simra, yeah, that's correct. Okay. So let's suppose if I was asked to calculate the LCM and HCF. So what we are gonna do? We are going to write 36 with its prime factors, that 2 square and 3 square over here, and as well as 48 equal to 2 raised to the power 4 into 3. Okay. So guys, in order to calculate the LCM, you people are going to first of all mark the common numbers. What is the common number? I can see 2 over here, that is common, and as well as I can see 3 over here, that is also common. Okay, so by selecting the common number, I'm going to select the smallest power, largest power in the LCM. So if I'm talking about 2, so here I can see there in the first number in 36, I can see there's 2 square, and in 48 I can see there's 2 raised to the power 4. So exactly I'm going to write the highest power in the LCM. Highest power in the LCM means that will be 4 over here. Okay, and what about 3? So when I consider that 3 is also the common number, so I'm going to pick the highest power, so that is 3 square. Okay, so here we got the LCM. The simplest way to calculate the LCM, first you are going to find the common number, and after that you have to select the largest power of that common number. Okay, so I found it that 2 is over here, so I selected the 2 raised to the power 4, and I found that 3 is over here, so I selected the power 3 square over here. Got it? Is it clear to everyone? Okay, now let me say is yes, and other people are going to answer me or not. Okay, so 2 raised to the power 4 is going to be 16, and 3 raised to the power 3 raised to the power 2 is going to be 9. When I'm going to multiply this, that's going to be 144 over here. Okay, that's quite simple. And when, let's suppose when I'm talking about HCF, when I'm talking about an HCF, so in HCF I can see this. In HCF we are going to select the common number with the smallest power. Common number with the smallest power. Common number with the smallest power means here I can say that 2 was the common number, but the smallest power was 2 square. And when I'm talking about 3, so the smallest power was 3 over there. Okay, so I selected 2 square and I selected 3. Then I did 2 square is 4 and 3. That's gonna be 12. 12 will be the HCF. Okay, one thing more that I want to tell you about it, that is, let's suppose if a number is having a prime factors like this, that's gonna be uh, 2 square and as well as 3 square, and as well as the number is having 5. Let's suppose, for example, it's an example, I'm talking about a prime factors of any number which I do not know. I'm just giving you an example. So in another number I would be having 2 to the power 4, 3, and as well as 7. When the LCM is taken over here, so remember one thing beta, 2 was the common one and 3 was the common one. Okay, in LCM we consider 2 raised to the power 4 and as well as 3 raised to the power 2. But with that I'm going to increase something. You have to write the missing elements which were not common in LCM, because there were nothing extra element. If I'm talking about this one, if I'm talking about 48, if I'm talking about 36, so there was no common number, no uncommon number. But here we got uncommon number, so we got 5 over here and we got 7 over here. So if we got 5 and 7, so in order to take an LCM I have to write 5 into 7 over here. But when it is an HCF, so I'm not going to write uncommon numbers. I am only writing 2 square and 3. Okay, is that clear? So that is quite simple formula, that if you are taking an LCM, so you have to consider the common numbers as well as with the uncommon numbers. But when I'm talking about HCF, so I am not considering uncommon numbers. Is that clear to you? Understood? Yes. So I hope that's easy and clear. So here we are going to move for some questions that they are necessary for you. So I'm just picking some questions from my question bank, and here I'm going to show you something. So we are going to start with the easiest question first, then after moving with the easiest one, I would see some tricky questions for you. I would find some tricky questions for you. So one thing more that you people should know that you will be having a word problems in this, means you would be having a word problems with the numbers of LCM and HCF. Okay, here you can see a question in front of you on your screen. So here we got the number 60 and 26 written as a product of their prime factors are, they are written over here, and 60 having a factor of 2 square into 3 into 5, and 126 will be equal to 2 into 3 square into 7. Find the largest integer which is a factor of both 60 and 126. So here we got the factors. A lot of times you will be having a prime factors in the question. Sometime in the question you are asked to calculate the prime factors, but not every time. Okay, so who is going to tell me that if we are talking about the largest integer which is a factor of both, so it means that I'm going to inform you the largest integer which is a factor of both. Factor of both means the largest integer is factor of both, which is representing highest common factor. Okay. Oh, I got the answer. That is, someone said 6. Oh, let me see. So if I'm going to calculate the highest common factor, so it means that I'm going to have 2 over here as well as 3 over here, and I can say this, that for calculating HCF I would be having 2 and I would be having 3. Yes beta, you were correct. So here we can see 2 into 3 is gonna be 6, because the highest lowest power of 2 is 1 and the lowest power of 3 is also 1. So I can say this, that 2 into 3 is gonna be 6 over here. Got it? Is it clear to everyone? Yes, I know that you are, yeah, okay. And if we are getting the smallest integer, the smallest integer which is exact multiple, so it means that we are talking about lowest common multiple. Okay, so here I got an answer, but let me see that is correct or not. Okay, I'm just checking. So here we got better do not use the calculator over here because it's a question from the paper one. Okay, so you can write 2 square, you can also write 3 square, and the uncommon numbers are 5 and 7 over here. Okay, is that clear? So I'm going to write 2 square, that is 4, 3 square, that is 9, and 5 and 7. So it's gonna be what? 4 into 5 is 20, and 9 is 180, 180 into 7, that's gonna be 0 over here. 7 into 8 is 6 and 5, 6 and 5, 7 into 1, 2, 3, 4, 5, 6. Is it clear? 2 square is 4, 3 square is 9, 5 is this, and 7 is over here. So 5 into 4 is 20, 20 into 9 is 180. When I'm going to multiply, that's going to be 1880. Yeah, it's going to be 1880. So, better check this answer. Then I just multiplied this one. 180 into 7, that's going to be 7 to 0 is over here. 7 into 8 is 56. 7 into 1, 7 into 1 is 7. 8, 9, 10, 11, 12. That's going to be 1260. I just counted from 14. 1260. We got 1260. Okay. So here we got the answer, and as well as I'm going to just pick another question over here. So we can see is another question. Yeah, I got it. But that is too much tricky. Let me just check the another one. Do I have easiest? Okay, student, just tell me that what is the meaning of perfect square before going for the another question. Do you people know about anything about the perfect square? What is perfect square is? Whose root is in decimal? No. Okay, just let me know what is 36. Is it a perfect square or not? And what about 49? Is it a perfect square or not? Yes, is it a perfect square and of 7. Okay. So guys, here we got another question. Express 99 as a product of its prime factors. We are talking about 99 as a product of its prime factors. So that is quite simple, and you can easily calculate this one. That by taking 99 and you are going to take an LCM, that is 333, and 3 into 11, and that's gonna be 11 into 1. So I can easily say this, that 99 will be having 3 square into 11. So is that clear? Is that clear to everyone? Yes, sir. Okay, I got it. Now read the another question, that is in part B. Find the smallest positive integer value of n for which 99n is a multiple of 24. So how you are gonna answer this? What does it mean? 99n is a multiple of 24. What does it mean? Sir, this type of questions confuse me. Yeah, it this type of question confused me too, because this type of question just check the knowledge of a student. So I can say this, that is quite simple, beta. Do not take it too much too much confusing question. That is quite simple. I'm gonna tell you. The smallest positive integer, the value of n for which 99n is a multiple of 24. That was your question. Okay, 99n is a multiple of 24. Let me know exactly what is the meaning of a multiple. So if I'm writing that 6 is a multiple of 2, if I'm going to write this, what does it mean? 6 is a multiple of 2. 6 comes 6 comes in the table of 2. Yeah, that's correct. 6 comes in the table of 2. So if you divide 6 by 2, that's gonna be 3 over here. Okay. So let's suppose if I am talking about that 6 divided by 2 gonna be 3 over here. So furthermore, if we are just moving to further, so we can say this, that 4 is a multiple of 2, and we can also say this, 15 is multiple of 3. Okay, can we say this? Yes. So if I'm dividing 4 by 2, so that's gonna be 2 over here, and 15 divided by 3, that's gonna be 5 over here. Okay, just let me know one thing. what does it mean exactly? When I'm just dividing 6 by 2, the answer is 3. What this kind of sentence is going to represent me? I'm giving it 2 minutes. Just think about it. What they were just saying. For yes, I got some answers from your side. So here I'm just scrolling it down, and if 6 is divided by 3, the answer will be 2, or multiplied by 3. Answer by 3, the answer will be 6. If we multiply 3 by 2, we will get 6. Okay, okay, okay. For the question will be 99, LCM of both 99 and 24. Okay, let me tell you one thing. Beta, when you are just dividing 6 by 2, because they have written this 6 is a multiple of 2, so it means that when you are dividing 6 by 2, that's going to be divide completely and no remainder will leave. Okay, like 2 into 3, that's going to be 6, and you would be having remainder 0. Okay, so it was quite simple when I have written over here that 6 upon 2, that's going to be 3. It means nothing should be remaining in the nothing should be remaining in the denominator. Okay, so when, let's suppose, when I'm just writing 5 is multiple of 2, so what's gonna be, what it's gonna be, it's gonna be like this one. You are going to write 5 over here and 2 over here, so you are going to read the table of 2, that's gonna be 2 into 2 is 4, and it will be 1 over here. So I can see the 1 is remainder over here. Okay, so you have to consider it about like, if remainder is 1, not completely divided, yes, not completely divided, remainder is 1. It is not a square factor, it is not a square factor. You can say that it is not a square factor, not a good sentence. You can say it is not a factor of 2. A square factor is something different. Okay, so you are going to write it is not a square, it is not divisible. Okay, so whenever we are just having this kind of sentence, so it means that the denominator should be cancelled completely. So I'm going to show you something. Let's suppose if I was dividing 6 by 2, so if if I'm going to divide 6 by 2, so let's suppose what is the factor of 6? What is the prime factors of 6? That's going to be 2 and 3, and when I'm dividing by 2, so that's going to be cancelled over here. It's going to be 3. Is that clear? So when I'm writing 4 divided by 2, that's going to be 2 multiplied by 2. It's going to be 2 over here, and 2 will be cancelled, and 2 will remain. And when, let's suppose I was saying that 15 divided by 3, so I'm going to write 3 into 5 and dividing by 3. So 3 both will be cancelled, remains 5 over here. It means the denominator should completely be dissolved or cancelled. Is that clear to everyone? This point is clear to everyone. I got one answer. Yes. So now you are going to read the sentence first. Now you have got about the meaning. You have known about the meaning. Like when I'm talking about, let's suppose, a multiple of 24. So when they are writing that 99n is a multiple of 24, that means 99 will be like this. 99n means I can write it like this one, 99 into n, and 24 is over here. And when I'm just going to just take prime factors of this, so let's suppose if I'm talking about the prime factors of 99, as I know that 3 square into 11 into n, and if I'm talking about the prime factors of 24, which I did not calculate and I'm calculating right now, so that's going to be 2 1 2, and 2 into 6, and 2 into 3 as well, and 3 into 1. So I can see that 2 cube and 3 will be over here. Is that clear? Is that clear? Yes. I got only one yes. I need more. That's the point. That was I was asking some more. 99 and can I write? Better let me know one thing. That can I write 99 and from here to here like this? Can I? Yes. And if I'm talking about the prime factors of 24, so can I write the prime factors of 24 and 99 like this? This one will be like just a second. I got a problem. Yes. Oh, just a second. I got some issue with this. It is oft. So now you guys can see. So I was asking a question that I could write 99 like this, and I could write this like this, and this will be like this. Yes, beta. Can I write this one as well? The last one. Yes. Okay. So according to the situation of the multiple, you have to understand about it that if we are having something in the denominator, so in order to be a multiple of any number, because they are the factors of the same, they are the factors of, am I right? No, they are not the factors of same. You can see over here, in 99 n will be having 3 square into 11, and 24 will be having 2 cube and 3. So they both are different to each other. But I just calculated the prime factors and just put it over here. Is it okay? Okay. So in order to be a multiple of any number, the denominator should be cancelled completely. That was my question. So you can see over here, 3 in the denominator which is situating in the denominator which we is having 3. So I can say that 3 can be cancelled completely in the denominator. In the denominator I'm talking about. And 2 will not be cancelled. So in order to cancel, I have to bring 2 cube in the numerator. So now then it will become completely dissolved. Is that clear? Is that clear? Yes, I got one answer and I got some more. Okay. So the extra number, whenever you are bringing an extra number, so the extra number will be representing by this variable. So you can say this n will be going to equal to 2 cube. Okay. Now, are we correct or not? So we can easily identify. Yes, that is 8. We can easily identify this. If I'm going to write 3 square into 11 into 2 cube, and if I'm writing 2 cube into 3, so you can see 3 will be cancelling over here and 2 cube will be cancelled. So it means they're going to be 11. Got it? Is that clear? So here we can say that is completely dissolved denominator and there is no remainder over here. Is it clear? I want some more answers. Oh, no, no. Answer is 8. I was just showing you that is 11. What is 11? I was showing you that what is 11, but the answer is 8 because we were just calculating the value of n that was 2 cube. But I was showing you when I put this value in the function or in the equation. So what it's going to be? It's going to be 11 when I put this value. But we are not considering about the value. We were not calculating the value of the final answer. We were calculating the value of n. So I hope so it will be clear. Okay, now I'm going to show you another question like this one. So you people are going to answer me about it. and the meeting is going to end, and you people are going to take a screenshot of this and again join the meeting with the same link after 10 minutes. Okay, the 10 minutes will be the break time. Think about the question and then join the meeting from the same link. So where's the question? Where's the question? Yes, I got. So here you can see the question on the screen. Take a screenshot because the meeting is going to end and you are going to join with the same link in 10 minutes. Boarding. Okay, beta. So where were we? I have given you the question to solve this one, and let me know the answer if you have done this. Hello, Simra. Where were you? You did part B. And what about part A and C? Haven't you done that? No, sir, not yet. So, can you do this or not? I will try, sir. You will try. You didn't try, right? Just a second. Okay, done. Simra says done. Oh my god, she has done all the parts. Okay, let me tell you one thing that what was in part A. So there was a question that is 324 square root. So beta, first of all, let me know what is exactly the meaning of a square root. A square root means that you would be having a power of 1 by 2. Okay. So remember one thing. When you are just putting under root 324 and you are going to solve this one. So you are going to write the prime factors over here like 2 square and 3 to the power 4. Okay, and remember one thing, that whenever you are just having this kind of numbers, so in a square root the powers should be multiple of 2. In a square root the power should be multiple of 2. So it means that when you just remove the square root, that's going to be 1 upon 2, and according to the rule of indices you can easily say this, that 2 raised to the power 2 is going to multiply it by 1 by 2, and I'm going to multiply 3 raised to the power 4 by 1 by 2. So I hope so it will be clear. Is it clear? Is it or not? What? Every number will be half, so 2 into 3. Every number will be half, 2 into 3. What does it mean? What you are just going to say? Yeah, every number will be half in the powers. Okay, you are talking about that one. Yeah. You are correct. So here you can see the power of 2 becomes 1 and the power of 3 becomes 2. So it's going to be 2 into 3 square, that's going to be 9. That means we are having an answer 18 over here. Okay, so what about part B? what we were doing in part B. There we got the largest integer, which is a factor of both. It means they are talking about the HCF. That is totally understood that they are talking about an HCF. So, okay, let me see what we have. 168 equal to 2 raised to the power 3 into 3 into 7, and 324 equal to 2 square and 3 to the power 4. So, uh, at the place of, if I'm talking about for the HCF, I can see this one and this one as well. So here we can conclude that the HCF should be smallest power of 2 will be 2 square, and the smallest power of 3 will be 3. So it's going to be 4 into 3, that will be equal to 12. We got the 12. Yeah, HCF is 12. Let's suppose we are asked to calculate an LCM. So beta, what should be the answer for the LCM? You people are going to tell me what should be the answer for the LCM. And I'm waiting for the answers. Oh my god, that is 54536. Someone told me. What about others? Samaya, you are going to answer me, or you are just calculating? Calculating, okay. Yeah, that was 4536. That was correct for from all of you. Okay, so that was my question. Not for, it was not written in the script. So I'm going for part C over here. What it should be: the smallest positive integer value of n for which 160n is a multiple of 324. That will be same as the previous one which we did before. So I'm gonna write 168 into 168n in the numerator, and in the denominator I'm gonna write 324. So here I can also say this, okay, I can write 168 into n divided by 324. So as well as if I'm going to write the factors of 168, so it's gonna be like 2 raised to the power 3, 3, 7 into n. And here we can also say this 324, it's gonna be 2 square 3 to the power 4 over here. Okay, that's correct. Okay, someone has find out the value of n. Okay, that's cool. Let me see. I can see that 3 is not gonna completely divided by this denominator. So I need furthermore, because for the sum 3, so I can say that I need 3 cube, or I need 3 square. You both are going to tell me about what we are going to have: 3 cube or 3 square. I'm waiting for the answers. Cube. So why did you say that the value of n was this? It means you made a mistake. And what about the other one? Yeah, that would be 27. Lamia, I'm waiting for your answer. My mistake. Okay, I got it. I knew. Cube. Yeah, that's cube. 3 cube. So we are going to have 3 cube more. So it means that n is gonna be 3 cube. In order to dissolve it completely. So it's gonna be 27 over here. It's gonna be 27 over here. So okay, now I'm going to show you another question in front of you, in which you are going to answer me something different, like you people know about what is the meaning of the square number. Okay, so where the root is possible, that means the number is in a square number. And exactly according to this, I'm gonna show you a question on your screen that you are going to answer me this. Okay, just start solving this one, and I'm just bringing another question in front of you. Now see who is going to answer first. The person who will solve first will not get anything except my praise. Okay, so don't think about any of the gift. Here I got one more question from the past papers. And searching another one for you guys. Did you ever see any one of you? Okay, we got an answer over here. So that is cube 3 to the power 2 multiplied by 7. Let me bit of what are you talking about? Part A, part B? Yeah, that must be part A. Okay, and c square multiplied by 7 and n is 5. Okay, she has done both part A. Okay, I got it. So what about part B? Are you solving? Because Simra has done this. Confused. So confused in the second question. Why confused in question 2 and HCF is 18? Okay, you are just confused about part A. I got question 2 part A. Okay, Simran, let me know that the small integer of k such that 198k is a perfect square. So what is exactly the meaning of perfect square? What is exactly the meaning of perfect square? The n is a number which will divide giving a whole number. Divide. It should be divide. Or there must be something different, something else except the divide. Okay. I'm just telling you. Just see over here. You both people are done with this part. That means I'm gonna write 63 if I'm talking about the first one. So it's gonna be 3 into 2 and 3 into 1 and 3 into 7 and 7 into 1 over here. So I can write for the part A, there must be 3 square into 7, that will prime factor. And if we are talking about 63 and divided by 35, so let me check that you people are did right or not. 3 into 7 into n, and I'm gonna write 35. 35 means 5 into 7. So I can say this, I need one more 5 in the numerator as a place of n in order to cancel it. So n is gonna be 5 over here. That was correct. Okay, you both people are correct that n was 5. And what about the second one? Here you got the smallest integer k. I'm talking about party. So remember one thing, beta. 198k was a square number. So it means that you are going to put all the factors over here of 198. Okay. So all the factors of 198 was 2 into 3 square into 11. And furthermore, you are having k. So you are going to write k over here. Now, check. What did I tell you about the square root? Whenever you are just having the square root, so you should be with the powers of even numbers on each number. So here you can see, here you got 2 with the power of 1 and 11 with the power of 1. It means 2 and 11 are not having the even powers. So you need one more 2 to become 2 square. That becomes a even power. And you need one more 11. So it means you are need to have this numbers as a place of k. Got it? So at that time that is going to be completely perfect square, because the perfect square should be having a even powers. So here we do not have the even powers, so I'm going to consider one more 2 and one more 11 over here in order to make it a perfect square. Did you get it? No, still not. Oh my god. Okay, just see over here. I'm giving you another example. Just let me scroll the screen. See over here. Why? That is why. I'm gonna tell you. Let's suppose you are having 2 to the power 2 as well as 3 to the power 2 and a 7 with this. And if I say that take a square root, so you are going to write 2 square, 3 square and 7, and you are just putting a power 1 by 2 over here. And this 1 by 2 going to multiply to every power, so that's going to be 2, and it's going to be 3 square into 1 by 2, and as well as 7 1 into 1 by 2. Is it? As it should be like this one, as I have written over here. Yes. Okay. So here we can see 2 will be cancelled completely and 3 will be cancelled completely. But you can see there is something different you got. 7 to the power 1 by 2. It will be in the answer 7 to the power 1 by 2. So it means it was not completely resolved from the square root. Is it? No. So that is totally clear. In order to solve the square root, you must be having the even powers. And if you have a calculator, so you can easily put these factors, the correct answer of this, and in the square root, and you would be having a decimal answer. But if I change this 2 square, 3 square, and 7 to the power 4, and if I am having a square root, so I'm going to say this 2 raised to the power 2 1 by 2, as well as 3 will be having power 2 into 1 by 2, and as well as having 7 4 into 1 by 2 over here. So here you can see the 2 will remaining, 3 will remaining, and 7 square will remaining. So it means the square root completely dissolved. Yes. So did you get it? That for solving the square root, you must be having the even powers on every number. So to whom I was expecting the answer, I didn't get an answer. Okay, so k is a number making it even. Yes, exactly. So here you need one more 2 and one more 11 to become an even powers for 2 and 11. Did you get it? So it means that the new value which you got, that will be representing the variable. So it means that k is gonna be 2 by 11, that will be equal to 22. Is it clear? Yeah, clear. Okay. Now come to another question, and here they have written over here, written as a product of its prime factor 360 equal to 2 cube and 3 square and 5, and write 108 as a product of its prime factors. So I'm going to write 108 and its prime factors. So 2 into 5, 2 into 4, 2 into 2 and 7, 3 into 9, 3 into 3, as well as 3 into 1. So I can easily say this, that 108 is going to have a factors of 2 square and 3 cube. Is it? Yes. What about part B? Find the lowest common multiple of 108 and 360, giving an answer as a product of its prime factors. Find the smallest positive integer k such that 360k is a cube number. 360k is a cube number. So, what we got with the cube number? I'm going to take a cube root of this. Oh, sorry, I just skipped the part B. So part B was the lowest common multiple. So if we are going to calculate the lowest common multiple, so I'm going to write 108 equal to 2 square and 3 cube, and as well as I'm going to write 360 equal to 2 cube and 3 square and 5. So here I can say this, that in the LCM I can have a power of 2 cube and as well as the 3 cube and as well as the remaining numbers, that should be 5 over here. Is it clear to everyone? Yes, sir. Okay. So it means that 2 cube is gonna 8 and 3 cube is gonna 27, and as well as 5, and 5 into 8 is 40 into 27. That's gonna be 1080, I guess. So 27 into 4, 4 to 7 is 28. Reduce 8 and 10. I'm gonna adding a 0 over here. So it's gonna be 1080. And when we are talking about part C, so what it should be, they were asking find the smallest positive integer k such that 360k is a cube number. So 360k is a cube number means I'm going to put the cube root over here. Is that clear? Why did I put the cube root? Yes, you ordered. And the other? Simra, are you going to tell me yes or no? Did you get this one or not? Yes. So here we got something, that 360k is a cube number. It means here for having a cube number, we should be having every power that are divisible by 3 on every number. So it means that the factor of 360 was 2 cube, 3 square, and 5 into k as well. So I can say this. I need, do I need one more 2 or two more 2, or I do not need 2? Do I need 2 for making a cube power of 2? 1 2 is needed. No. Lame was saying no, and Simra was saying 1 2 is needed. Simra, let me know why. Why do I need one more 2? Because if I add one more 2 over here, that's going to be 2 to the power 4, and which will not be divisible by 3. Oh, okay. 3, sorry. No, not 3. We do not need 2, I guess so. Because 2's power is 3, and that is totally divisible by 3, isn't it? We need a power which are divisible by 3. So 3 is divisible by 3 as well. So I think I do not need any of the 2. What do you say? I'm talking about 2. I guess you were talking about 3. Okay. So 2 is not needed, but 3 is needed. So I can say that one more 3 I need. And what about 5? How many 5s do I need? How many? 2 more 5. What about you, Lame? Was she correct? Yes, sir. Okay. So we need 5 square. So I can say this, that k is going to be equal to 3 into 5 square, which means that 5 square is going to be 25 into 3. That becomes 75 over here. Okay. So the value of k will be 75. Is that clear? Is that clear? Okay. Okay. So I guess we are done with today, because we have done a lot of questions today about the factors, multiples, and some of the things. So in the next class, which we are having on Friday, I guess. Yes, on Friday. So at the time, I'm gonna discuss you with the you can say that the word problems of the prime factors, and as well as some of the questions of the past classes, like this one, this questions, and some of the other questions which I'm going to discuss you with. So I hope today's class is clear.